Okay, one petal of the rose curve given by cosine of 3 theta. All right, we don't need to carve out this whole thing. We don't need to graph this whole thing. But let's graph enough of it. You know, the rose curve has a lot of symmetry. If you can just find the limits on theta that give you just half the petal, you'll be in good shape because you can multiply by 2, and then how many petals will this thing have? Oh, no, it's just one petal, actually, so never mind. But if it's odd, I believe it'll have 3 petals. If it's even, it'll have twice that. Yep. And if you don't remember, just graph in your calculator, right? Polar mode. So let's start with 0 theta. Remember, you plug in for theta to get a little picture of this thing. And then it's nice to plug in the value that, well, okay, let's find this first of all, and then I'll state that. So what's the cosine of 3 times 0? Yeah, it's cosine of 0, which is 1. And then it's nice to plug in the value of theta that would bring you back to 0. Okay, a radius of 0, because it brings you back to the pole or the origin if you do that. So what would be that value? Well, we know that what value can you take the cosine of to get 0? Right, in general. Pi over cosine of what's the first angle starting at 0? What's the first angle after pi? For just the cosine function, guys, forget about this. This does not exist. Just the cosine function. Let me say cosine of x so you don't relate it to what we're talking about. Cosine of pi over 2. Okay. Everybody wants to just go to the answer. If you take your time, you're going to learn things, right? I know you don't want to, but get in the habit of taking your time. Experiment. Play with these things, and you'll learn a lot from that. It's like when you play with your phone, you learn a lot without even trying, right? Same thing with math. When you play with math, you learn a lot without even trying. Use technology, right? Just see what happens. So if we want 3 theta to equal pi over 2 then, so that we get r equals 0 popping out, what does the theta value have to be that we plug in? Multiply both sides by 1/3, pi over 6. So that's the next value I'm going to plug in, pi 6. When I plug in pi 6, 3 times pi 6 is pi over 2. Cosine of pi over 2 is 0. So what's happening when you do that, this is a good chance also to review how you graph in polar coordinates. You don't think right, left, or right, left, up, down anymore, right? You don't think rectangularly. You think radially and angularly. So if you look in the direction of 0, not radians, but 0, not degrees, but radians, in other words, that value, you go out a distance of, radially you go out a distance of 1. Now that does happen to correspond with 1, 0 in rectangular coordinates too, but to get to it, you think about it in a different way. You look in the direction of 0 radians, and then you go out radially from the origin a distance of 1, right? Different thought process. So pi over 6 is like 30 degrees. So looking in the direction of 30, would you say that's about 30 degrees right there, that angle? Close enough? So looking in that direction of 30 degrees, what happens? The radius, you actually go out a distance of 0. So let me change that to green. Why did I even put in that? It's kind of like a tangent line. Why did I put that in? Because it kind of tells you the direction that the curve is coming in at. Right? Now that's actually going to turn out to be half of one petal. And that's all we need. So we want the area of one petal. We can get the area of half of one petal by integrating theta values from 0 to pi 6. So just multiply by 2. Okay, but I'm getting ahead of myself. Let's set it up. So the integral, we're finding area, so what's the value of the integrand? 1, but then when you introduce the differentials for polar coordinates, you need the r dr d theta. And then, okay, now this is where it gets a little bit tricky. When you draw on your spoke, You draw it in radially, so you're going to draw it from 0 to when you hit the boundary, right? Something like that. There's a representative spoke, a radial spoke. Now, if you think about then R, the inner limits of integration, what's the value, the R value of this point? You know it's 0, right? So 0 to, what's the R value of this point? Yeah, I pointed at this one, but it doesn't really matter. You could draw the spoke anywhere, and the R value of this point would be 0, okay? The R value of this point changes, hold on. The R value of this point changes depending on where you put the spoke, right? It's a function. And that's why this is weird, because most of the time it's constant. So what's the function? Right? Let me put the 2 out here before I forget. So 2, and then double integral, okay, inner limits 0 to cosine of 3 theta. And then what does theta run from? 0 to pi 6. And then there you go. Does that make sense to you? We might want to at least go through the first step of this one, because there's something I might want to remind you of, an identity perhaps. So let's talk about the inner integral here. When it's just R, right? So by the way, you can't split this up. You can't separate it because the upper limit, inner limit's not constant. So you integrate the inner integral, and what do you get? 2, okay, this guy stays the same. The outer integral stays the same. 2 times the integral, 0 to pi over 6. And then you get what? R squared over 2. Oh, let me put that 2 on the outside. Just R squared, evaluated from what to what? 0 to cosine of 3 theta. And then we still have d theta on the end. Yeah. So what do you get inside? Yeah, so this is what I wanted to remind you of then. 0 to pi over 6, cosine squared 3 theta d theta. So you have to channel your calculus 2, right? You can't integrate that as is. You need an identity. What's the identity? The power reducing identity. However, and you have to remember that power reducing identity, when you substitute that in, it doubles the angle, right? So if the angle is 3 theta, it doubles it to 6 theta. And that would be easy to mess up, wouldn't it? So the power reducing identity in general is like this. The cosine of cosine squared x, let's say, is equal to what? 1 plus cosine of 2x over 2. But if the angle isn't x, it's 3 theta, then you take double 3 theta, you get 6 theta. Does everybody see that? Okay. So I'm going to pull this 1/2 out front, and then write it as 1/2 integral 0 to pi 6 of this part, except in for x, I'm plugging in 3 theta, so 1 plus cosine of 6 theta, that turns out to be d theta. Okay? Just remember, when you integrate the cosine of 6 theta, you have to multiply on the, so you get sine of 6 theta times 1/6, right, on the outside. And I think I'm going to let you guys take it from there.